Kia ora. So today I'm looking at the second slide set for investigating bivariate data, the Year 13 statistics standard. We are looking today at scatter graphs and the discussion of them. So this is the second part after we've done the purpose and decided what we're looking at. We're actually trying to find out whether there is a relationship between the data sets that we've been given. So what we need to do is draw a graph that we can talk about. We want to just look visually at the graph and make some statements about what we can see off the visual graph in order to start our investigation. So we'll be using NCEA Grapher, and we want to draw a graph that has the variables, the explanatory and the response variable, remembering that the explanatory variable goes on the x-axis and the response variable goes on the y-axis. We need to make sure our title is something that describes the graph we're looking at, and we also need to make sure we can see the individual dots clearly. So if we have a look here at NCEA Grapher, I'm going to look at the rugby data here. So I want to draw a picture of that. You can also import your data from a clipboard. So if you're given data to look at, you can import it here. We're going to look at the scatter graph, which is here. And then we need to put in our variables. So we're going to use the height, which is our explanatory variable, because we can't change our height, but we can change our weight, so we will make that our response variable. So here's our graph that we're looking at. And it's a bit of a mess, but we can see certain things about it, and we'll talk about them later. We need to put a title in, so height and weight of New Zealand, not New Zealand, just rugby players. And we also, in our X and Y axis, we want to say what they've been measured in. So the height is in meters and the weight is in kgs. And we need to make sure also that we can see the dots clearly. I can see them quite clearly here, so that's this part here. Okay, we update our graph, and then we can right-click to copy our image and put it into something. All right, so that's that. So if we have a look at this particular graph, which is the data we're looking at. So you can see that I've changed the BMI, which is a percentage, the weights in kilograms, and its weight in kilograms versus the body mass index. I should probably put of whom in the title as well. So that's an example of the graph. So I've put the instructions in here as well. So how to upload your data, what graph type to choose. Variable 1 is the explanatory, variable 2 is the response, and that bit down the bottom is to make sure that your graph is visible. All right, so change the title so that it explains the graph. Add units, alter the size and transparency of your dots if you need to. One thing you might need to know is if you only want to look at females and you've got data for both males and females, an easy way to do that, to get rid of the male data, is just to press sample and the more button, then you'll be able to select sex and pick the group that you want. Then you right click on this graph and put it into your data. So this is the graph you will write your scattered description from. So when we describe it, we've got many things to talk about. A lot of teachers teach TASOG, which is a very similar run through to the instructions I've got here. So the first thing we want to look at is which direction the data appears to be moving in. So you can see in this one that the data is sort of moving in a positive direction, going from the bottom up to the top. This one we call a negative direction because it's going from the top down to the bottom. So the general words here is I've got a positive relationship or a negative relationship. So in this particular one, I've written there is a negative association between mean annual temperature and elevation in Nevada. As the elevation in meters increases, the mean annual temperature decreases. So you can see that that's from here to here. Does this make sense? Does it match what you expected? Okay, so that's important things to ask yourself, and it's probably appropriate to do a little bit of research about whether that is backed up by something else that you can find on the internet. Always when you're writing it, remember that you are writing as the x variable is increasing. So the x variable never decreases. We're always looking at it from this side across to here. So as the x-axis increases, does the y-axis decrease or does it increase? The next one to look at is whether the data is looking like a line or linear. So if it looks like it's sort of forming a line or very close to a line, we would call it a linear association. But you can see in this one, it doesn't look like a line, so that's a non-linear. We don't need to know what it actually is. We're just doing linear versus non-linear. So in this example, there appears to be a linear relationship between the math SAT scores and the verbal SAT scores as the data forms a line. So we can see that there's approximately a line going upwards. So we would write that it's positive as well. Next thing we need to talk about is the strength. So that's how close are the dots to your trend that you are describing, your linear trend or your non-linear trend. So you can see in this particular case, this is a strong association because it looks almost like a line. This one is pretty strong as well, but we might go for a medium, moderately strong, a moderate negative relationship here because the dots are quite a long way away from an imaginary line through the middle. This one, they appear to be a little bit closer, so we could mix those two words together and put a moderately strong. But a strong relationship is pretty good. The last two, the weak, so that's when you can see that it is a line, but where the line is a bit of a guessing process. So it's a weak positive relationship in this case. And this one, well, I can't see any line at all. So there is no strength. So there's no relationship as such. So in this particular one, the data seems to have a moderately strong relationship, which I will investigate further, would be part of what we write. Other things that are worth noting are groupings. So you can see in this particular graph, I can see I have grouped them in color, and I can see that there is a grouping here, probably would describe this grouping together, and this is a separate group. So I've been able to actually identify groups within my data set. Same here, I've got a group here and a group here. Quite often these are formed by male and female relationships in any sort of animals, humans, and even species of trees and things like that. We also want to talk about possible outliers, and an outlier is not a point that's on the end of our line. It's one that's the furthest distance away from our line, and we'll talk about that a little bit later. But you can see this guy over here. He's our outlier, not this one down here. He's not an outlier. He's still in our present line of relationship. So just because a point is further away from the other points doesn't necessarily make it an outlier. An outlier is the ones that are far away from our regression line. It also may be that an error has occurred with that point. So make sure you're looking to see whether the data is correct. Okay? So that's how we describe our graph from the visual. Thanks for listening.